Okay, let's continue on with these triangle congruence experiments. This is number 4 down here. If we are guaranteed 3 sides in one triangle to be congruent to 3 sides in another triangle, does that guarantee the triangle angles to be congruent? And in our similarity unit, remember, it wasn't that these sides were congruent, it's that the sides were proportional. So just to show you this experiment, it says everyone construct a triangle with a 2-inch, 3-inch, and 4-inch side. So I'll show you what this looks like, how to do this. What I did is I laid out my links right here, and I'll grab them with my compass. I'll set the link down there and copy it. I've already done the 2-inch right here. So I'll go over here and grab the 3-inch side and just look at the possibilities of where I could place it. So there's my 3-inch. I'll just swing an arc up here somewhere. I know anywhere from this point to that point is 3 inches because that's a radius of a circle. And then I've got to do the 4-inch obviously on the other side. So that's pretty straightforward. Then I have to put my compass on the other end. So it's got to be here. And when I draw that up there, there's only one place that it'll cross. I can't get it to cross anywhere else. So I could do it there. I mean, I could swing my compass this way for a 4-inch side, but then whenever I go back to my 3-inch, I'll show you that one in just a minute. So I know on this one up here, to connect the dots, it goes here and here. And again, if I did the 3-inch side, the only way I could get that to go and meet down here, it would end up looking like this, which is going to make this weird little design right here. I'll let you see it. Like it's still making the same triangle. Okay, that's the 2, that's the 3, that's the 4. Here's the 3, there's the 4. Okay, so what if I started with the 3-inch side and I chose to put maybe a 2-inch segment on one end? Okay, so here's my 2, like that. And that means I got to put the 4 on the other. So the only place I could put the 4 would be to do something like this. So if I connect these once again, that, if you look, it's making the same triangles we had over here. It's making the same one. I could probably get that to fit right on there if I did cut them out and place them in there. Let's try it one more time with the 4-inch side. So that means I need to put a 3 on one end, a 2 on the other. So the only place this is going to meet it is right there. So once again, you can probably see this happening. I am constructing the same triangle. I mean, it ends up being the same one. This is the 2, that's the 4. So what are we demonstrating right here? There's only one way for this triangle to piece together. If I took the time to cut all these out, I think you would see that they lay exactly on top of each other. So we could say that all the points coincide. And so then you would also see that the angles are the same, or we could just measure the angles. For example, that angle up there ended up being 30. This one did as well. These over here did as well. And we could verify that all the angles are the same. And they are. So the big idea here is that, yes, this is another yes that we need to answer. Yes, all angles ended up congruent. Thus making all 6 parts congruent. So these two are just like last unit, okay? They work to prove similarity, but that's only when the sides are proportional. And they also work to prove congruence. That's when those sides are congruent and all those sides are congruent. Okay, so this is another big idea that's going to be important for us. This will carry on throughout the unit.